Good morning, everyone. So in today's webinar, we'll be just discussing about the electrical load list for any of the HVAC projects. And that is what we are more focused to determine in today's webinar. And this is one of the important part that a HVAC engineer have to do. Okay, this is not a part of the electrical engineer because electrical load list for the HVAC that is being given by the HVAC engineer, and it is being collectively combined with the other electrical loads by the electrical engineer. So for that we have to give this electrical load list detail to the electrical team. Okay, so let's start with this today's webinar. Okay, so in the electrical load list, what are the other benefits that we have to, what are the things that we have to provide? The first thing that we have to provide, it is the, I will just write it here. What are the things required to prepare electrical load list? If you will disturb, then I will just prepare electrical load list. So what are the things that is very much necessary to prepare the electrical load list? The first thing that we have, number one, that is the equipment name. So we must have that what exactly the equipment is, whether it is the chiller, whether it is the AHU, whether it is the FCU, pump, cooling tower, whatever it is. So I will write here whether it is the chiller, AHU, FCU, pumps, cooling tower, etc. Means the major power consuming devices in any HVAC project that we will write here. That is the first thing. Second thing that we must have, that is our equipment tagging. Equipment tagging. What exactly tagging means? Tagging is something where we can have the equipment number. That is, suppose there are three chillers are there. So chiller 1, CH1, CH2, CH3. So that is the tagging of the chiller. So equipment tagging. Third one, that is the power requirement. Power requirement. Prior to that, let's write here, that is quantity of equipment. Quantity of equipments, and here we need to define working and standby also. Working and standby also. So here we need to define this. Fourth number that we have here, that is our power requirement. Power requirement, here we need to define what? We need to define the phase, voltage, and frequency. Okay. Then Total power consumption per equipment. Consumption per equipment. So this value from where we'll be getting this value? We'll be getting this value from the manufacturer. The manufacturer will provide this value. From the manufacturer. Okay. And in that in this, that is the power requirement, here we also came to know that what is the power factor and all these things. So that is a requirements, detailed explanation in the power requirement. So these 5 are the major things that we need to define. Okay. Now, what are the outcomes of electrical load list? Major outcomes of electrical load list. Outcomes of electrical load list. Number 1, that is your total power for the HVAC equipments. Total power for the HVAC equipments. This is what we would be getting. Total power of the HVAC equipments. Accordingly, the transformer will be selected. Accordingly, transformer will be selected. Okay, so that is the first major outcome of the electrical load. Second thing is what? Total current required. Current required to run the system, to run the equipments. Number 3, that is your type and capacity of outcomer. Type and capacity of outcomer required. So what exactly the outcomer is? There are basically generally these three common outcomers are used. That is your MCB, MCCB, ACB. Miniature circuit breaker, molded case circuit breaker, and ACB, it is your air circuit breaker. Okay, so these are the major types of outcomers that we use. Fourth point, that is your cable selection for the equipment. Selection equipments. So here we'll be writing the cable size. That is the core and square mm, and whether it is for aluminium and copper, aluminium or copper cable will be used. So this is what we will be determining. So these are the four major outcomes of any of the electrical load list which is prepared for the HVAC project. This is for any HVAC project. For any HVAC project. Okay. Now let's try to determine one. I'll be just trying to prepare one electrical load list for any of the HVAC project. Okay. So let's go through the Excel sheet and I'll be just trying to prepare it. Okay. Let me open that sheet. Meantime, just hold on. I believe the screen is visible to you. Here we have started from here. I will just explain it. The serial number is there, equipment name is there, tag, equipment tag, that is the tagging of the equipment. Phase is required, that in which phase, whether it is in 3-phase or single phase. Then quantity, then redundancy. What is the working and what is the standby? In numbers that we have to define that how many units are working and how many units are in standby. Rated power per equipment, that we have to write that per equipment how much power it is consuming. This value we would be getting it from where? We would be getting it from the manufacturer. Now total power is what? It is for all the equipments. That is what we are determining here. And phase we have already written here, so no need to write phase here. So we will delete this column. Then power factor is there, current is there, that is in fact definitely this power will be at the full load. That is your full load power. Both these are at the full load because we have to determine the cable and we have to determine the that is your outcomer, and it will be as per your maximum power. Okay, so it will be at full load. So from we have the power factor also. So generally in India, the power factor which is used, it is from 0.8 to 0.9. Current, we will determine the current, at how we can determine the current. Then factor of safety is there. We can take 20 to 25% factor of safety. So corrected current is what? That is after adding your factor of safety. Then type of outcomer, we will also write, that is your capacity of outcomer selection. And then we will do the cable size. Okay, so let's start with this. I'd be just illustrating it with one project example, and I'd be just showing you one BOQ that is being prepared after the detailed designing, and we'll be trying to do the electrical load on that particular project. Okay, so let me open that BOQ and then we'll be discussing. Just give me 2 more minutes. I am just opening that particular BOQ. Is this BOQ visible to you? From here it is there. Okay, so what we will do, we will be just trying to prepare the first major equipment that we have, that is the supply, installation, testing, commissioning of air-cooled screw chiller. Okay, and what is the quantity? Two numbers are there and both are working. Okay, so let me write here in that electrical load list that we are preparing. Okay, so serial number is 1. First one that we have here, that is your air-cooled screw chiller. I'd be just trying to do it for 1 or 2, and then you can accordingly do it for the others also. Okay, air-cooled screw chiller, and its capacity is 110 TR. I will not describing all the details also, and both. And second, first of all, I would like to write down all the major equipments, and then I'd be trying to do the electrical load calculation. After that, we have a pump set. So primary pump, it is that is for 264 US GPM, and secondary pump, it is of 528 US GPM, and one working, one standby. So here it is 3 numbers, 2 working. As you can see here, for the pumping system, we have a primary pump, which is 3 numbers, and here it is 1 standby, and here it is secondary pump. We have it will be 2 because 1 standby will be there. Okay, so I will write here in the electrical load list, second major equipment, that is your primary pump, and this is of 264 US GPM. Okay, and its quantity will be, I will write the quantity here, phase I will write I'm sorry. Now I think it is visible. The second equipment that we have, that is our primary pump, and it is of, what is the quantity of that? It is in 3 numbers, and standby it is 1 number. Okay, and chiller, its quantity is 2, standby it is 0. Okay, then we will come to the secondary pump, and it is of 528 US GPM. That is of 528 US GPM, and this is of 2 numbers, 1 working, 1 standby. Okay, 1 working, here 2 working, and here also 2 working. So this is for the secondary pump that we have. Now coming to the AHU part, In AHU we have floor mounted AHU, that is floor mounted AHU. This is of 11,000. We can since I know the details, so I'm just writing it here. 11,000 CFM. Then again we have, it is of 10,000 CFM. Then ceiling suspended AHU, this is of 7,000 CFM. Again we have ceiling suspended AHU of 5,000 CFM. Ceiling suspended AHU of 3,000 CFM. And 2,000 CFM. I will just write the quantity of all these. Total quantity of 11,000. It is two numbers. This one it is 3 number. This is 2 number. This is 1 number. And this is all are the working. So I will not write more equipments here. I believe you understand how we have to do that. Okay. Now let's write. Similarly, we have the FCU also. In 10th point, we have FCU, that is your fan coil unit. FCU, that is of 600 CFM, and this is of, all AHUs are working. There is no standby in that. So we need to write it as per our project requirement. Okay. So that is of 2 numbers and both are working. So this I have written as per the project, that as per the BOQ that I have shown you. Now how we will write? We will write as per our project requirement. Okay, so you need to check with your project that how what are the things, what is the redundancy in your project, what is the working and what is the standby in that. Okay, now let's start with the I didn't understand, Mr. Parvez Alam, standby quantity. Why I have to change? Because sorry. You are right. So all these all are working. So it should be here, and standby it will be 0. You are right. Okay. So let us start the load calculation, that how we can do the load calculation. First of all, that we have to provide the tagging number. Okay. The tagging number is what, that how we can just and that tagging number is also available on the chiller also. So let us start with CH1, that is your chiller 1. This is your chiller, it will be your chiller 2, CH2. Now there pumps will be there, and sorry, chiller 1 comma CH2. So both the chillers are there. Now for the primary pump, PP1 comma PP2 and PP3. That is your primary pump 1, 2 and 3. Then secondary pump 1, secondary pump 2. 2 secondary pumps are there. Now for this AHU of 11,000, AHU 1, AHU 2. Here we can write AHU 3. So we are just providing the tagging AHU 4, AHU 5. Okay, so that it can be easily recognized. Now here it is your AHU 6, HU7, HU8, HU9, HU10, HU11, HU12, FCU1, FCU2. Okay, now phase we need to write. So this detail, it is being available in the technical documents of each and every equipment. Generally, major equipments comes in a three-phase mode. So these all are in three-phase. Okay, all these pumps and HUs except up to 2000 CFM, there is a chances that we can have a single phase motor also up to 2000 CFM. But above that, we have an option of three-phase motor only. So I will just write it three-phase. Here we will write single phase, and here also we will write single phase because this FCU, it comes in a single phase mode. Okay, so this detail we have already we have prepared. Now let's proceed ahead. And do the calculation for the others also. Now rated power. So this power, it is being given by the manufacturer. Now for example, I'm just writing it by own as per the experience. That is the power given by one chiller. It is around 1.3 kilowatt per ton. So that is the maximum I'm taking, equal to 1.3 multiplied by 110. So 143, it is the power that it might be consuming. So I'll be just writing it 143, and this power, it is in kilowatt. It is in kilowatt. Okay, so 143 kilowatt per chiller it is consuming. This value we will be taking it from where? This value we will be taking it from the manufacturer. I'm just reminding it. The manufacturer will provide us a technical detail. In that we have that particular rated power. That is rated power at full load. I will just write it at full load. At full load. Okay. Now total power is what? How we can determine the total power? We will just put a equal to sign. This is the rated power multiplied by, that is your working quantity. That is what is the working quantity. We will just multiply to get the total power in kilowatt. Now power factor which is used in India for three phase, it is 0.8. So for three phase it will be 0.8. So we can go up to 0.9 also. That we need to check it with our electrical team, that what is the power factor. So for all three phase we will be having the same, that is 0.38. Now current, how we can determine the current? So let us see that how we can determine here. I will just write here for single phase, power equal to VI, where P equal to power in watt, V is voltage, V is the voltage, and its value it is in 230 volt in India, and I is the current in ampere. I is current in amperes. So this is for single phase. Now for three phase, power equal to root 3 VI cos phi, where P equal to power in watt, power in watts. V, it is again voltage, and it will be 430 volt in India. 430, 420, 410, all these are same things. Okay. I, it is your current in ampere. Current in amperes. Cos phi, it is your power factor. And its value it is 0.8 for India. Okay, is it okay? And phi is what? Phi, it is your phase angle. Phi, it is the phase angle. So now let us try to determine the current here. Now since this is a three phase, so how we can determine the current? If we want to determine the current, so current is what? Power divided by √3 voltage and cos phi. So what we will do, we will just put an equal to sign here, and just insert one more column here. We will insert one more column here. And here we'll be writing that is your total current amperes. This is current per equipment. Okay, so per equipment we are determining. So how we can determine? We'll just put a sign equal to sign, and then we can delete this one also, because this is not required. Okay, so current per equipment, how we can determine? We will just put a equal to sign. See here, since this is for a three phase, so how we can determine this current? I equal to P divided by √3 V and cos phi, and we know that cos phi value it is 0.8, V it is your 430, and √3 it is your 1.732, and power we have here. So accordingly we will do here equal to, we will click on the power, that is for 1 unit, but this is in kilowatt, we need to convert it into watt. So we will multiply it by 1000 and then divide it by, in bracket we will write √3 value it is 1.732, multiplied it by voltage is what? 430 volt, multiplied it by 0.8. So we have written here, it's better we can have, just hold on, here you can write one more you can add one more column here, and you can write voltage also, rated voltage. That will be far better, it will be much more clear, and its value it will be in volt. Okay, and it is 430 volt for here, and it's 230 volt here. Okay, now let's determine equal to sign. total power per equipment 143 kilowatt. After that, it will be multiplied by 1000 to make it in watt, divided by bracket start. That constant value, that is root 3, is 1.732. Then we will multiply it by what? Voltage we have written here, and then we will multiply it by power factor we have written here. Okay, so bracket close and enter. So this is the current that it will require for per equipment. Okay, now let's decrease the decimal. Try to have it in a whole figure so that it will be much more clear. So 240 amperes it is required. The total current required, that is 240 multiplied by that total working. Okay, so it will be 480 amperes it is requiring. Now after that we will write the corrected amperes, that is after taking some factor of safety, that is at the rate FOS with FOS at the rate 10 or 15% we can take. So 10%. Okay, so what we can do, we can just take it equal to, so for each chillers we will be requiring one outcomer. So we'll be selecting this one multiplied by 1.1, that is taking a factor of safety with 10%. Right, FOS is the factor of safety. So this is the current required, 264. Now type of outcomer, selection of outcomer, and cable size. Okay, these three things we will be having a detailed discussion once we will be having a webinar on the basics of electrical that we have already shared with you, that we have one webinar on the basics of electrical. So we will go in depth. Here we will just write that outcomer and selection of outcomer. So outcomer is something, let me write here. I believe this is clear to each and everyone, these single phase and three phase. Okay, now for outcomer, let us write here. Let me write here. Okay, let me write here outcomer type as I have stated. So up to 0 to 63 ampere we will be using MCB. Then from 63 to 800 amperes we will be using MCCB, and above 800 ampere then we will be using the ACB, that is your air circuit breaker. Okay, so type of outcomer is what? Since this is 264, so 264 lies in this, so we will be using what? We will be using the MCCB here. So this will be your MCCB, and its capacity will be what is the capacity of MCCB? So that we will be selecting capacity, it will be as per market availability. So what is the next market availability? Anyone? Will be as per market availability. ELCB is also there. ELCB is also there. Okay. So can anyone have any idea that what would be the selected capacity? For that, we will just refer the catalog, and accordingly, its next higher model. So next higher model will be selected. Higher model will be selected. Okay. Right. So for 264, from after 240, we have an option of 300. So 300 ampere. That is your 300 amperes outcomer selection will be there. Now, accordingly, the cable sizing will be done. Now, for cable sizing, we will be just illustrating it. Cable sizing, it will be in core and square mm. So it will be like this. This is your core multiplied by square mm. So this we will be learning in the basics of electrical. Okay. So although it can be done by the electrical engineers also, so how much core and how much square mm, and then we have to write the material also, whether it is copper or aluminum. We have already taken a factor of safety of 10%. Somewhere in some of the cases, the client agrees to have a factor of safety of 25% because they don't want the that outcomer or cable to be short circuited. So for that, sometimes it is recommended to have a factor of safety of 25%. But generally, on a safer note, because if we increase the factor of safety, definitely the capacity of the outcomer and cable size will increase, and that will give an impact on the cost. Okay, so accordingly, it will be done. So in this way, we will be just doing it for each and every other equipments. Okay, in this way, we'll be doing for each and every cable sizing. We'll be just discussing once. We'll be discussing the basics of electrical there. Okay, it is in core and square mm. For example, in three phase we have 3.5 core and 4 core also, and square mm we can determine it. Yeah, how to find core and thickness, that we will discuss in the basics of electrical webinar that we have, because that is a detail. Because in copper we have, let me discuss few things. That is for copper, current carrying capacity. Capacity we have in 1 square mm, in 1 square, it is 2.2 to 2.4 amperes. That is basically thumb rules. And for aluminum cable, current carry capacity, that is in 1 square mm, it is 1.2 to 1.4 amperes. Okay, so accordingly we have the ampere, we have this ampere. If we divide it by 2.4, we can get the thickness of the cross-sectional area of the cable. And core, it will be for three phase, it is 3.5 core or 4 core. For three phase we have, and for single phase we have 1 core or 2 core. This is for single phase. So we'll be discussing in detail once. We'll be discussing the basics of electrical there. Okay, as of now I've just explained it in a short way that how we can determine it. So what our basic motive today is to just determine this total current. Okay, this is the total current, and accordingly if we do it for all the major equipments, so suppose this is for the chiller, we did similarly for the pump we will do. I will just try to do it for one. For example, for 2000 CFM AHU, the rated power that we have, suppose it is 1.2 kilowatt, and this is for a single phase we have. So how we can determine what is the total power? Its quantity will be this multiplied by working quantity. So this is the total power. Power factor we will not use. Current, how we can determine? Since for single phase, it is power equal to P equal to VI. So I equal to P by V. So we will write I is what? Current in amperes. It is equal to power by voltage. So this is the power. It is in watt. We will just multiply. It is in kilowatt. We will multiply it by 1000 to get it in watt. Divided by voltage. It is 230 volt. We have written here. We have written the 230 volt. So it is carrying only 5.6 ampere. Okay. So that is per equipment 5.2 ampere. So this is how we can determine. For that we can just have a single MCCB is there. So outcomer it will be MCB, or we can have a 6 ampere MCB also for this particular. Okay. So in this way we can do that. I believe this is clear to each and everyone that how we can just from the all the major equipments we'll be doing it in the same way. We will just drag it to have the value there. Okay. This value we will be getting it from where? I will just try to mark this value we will be getting it from manufacturer, from manufacturer. Okay. I believe this is clear to each and everyone. Now we can have a doubt session where you can discuss your doubts, whatever doubts that you have, and then we are at the end of this webinar, because this is a very short webinar, and in this we just learned that how we can just prepare electrical load list. So only the preparation of electrical load list, these three things, the things that we have discussed here, basically the cable selection, this we will discuss in the upcoming webinar that we have, that is in the basics of electricals. The details have been already shared with you. You just go through that. That is a cable selection. One of the important part is there. So that we will discuss in that particular webinar. Now, if you have any doubts, so we have 3 to 4 minutes. We can discuss your doubts. Else, we will just end this webinar. Right, factor of safety, it varies from region to region. It varies from client to client. That sometimes client is asking for a higher factor of safety. So there we would be taking 25% factor of safety there. You can ask your doubts. You can come up with your doubts. Outcomer is something that is your means from where the current we are taking it for that particular equipment. That is one outcomer is there. It can be your MCB, that is your miniature circuit breaker. It can be your MCCB, molded case circuit breaker. It can be your ACB or ELCB is also there. So a circuit breaker. So accordingly we will select the outcomer. That is the power cut option for that particular equipment. Generally we have seen that in our home we have a separate MCB for the AC, because that from that we can just switch off that particular equipment. We have an MCB for rest of the lighting. We have an MCB for major equipment. So that is just an outcomer type. Surely we will be sharing you the details of the recorded videos, details of this particular recorded video. When will be the basics of electrical webinar? So basics, we have a separate webinar. In that we'll be discussing in detail for the MCB, MCCB, ACB, ELCB, all these things we'll be discussing there. So that you can just go through this, go through the webinar link, and from there you can see that what is the schedule. Okay. Just give me some time. I'm just there's so many queries it is coming out. So if the circuit breaker will be selected for higher capacity, Definitely circuit breaker, it will be selected for the higher capacity only. It can't be at the lower capacity. Okay, we will just select a one higher model. Suppose the purpose of factor of safety example 20 HP VRF audio is having a 16 kilowatt power. So how to select the transformer for such system? See, the transformer, it will be selected according to this load. How the selection of transformer? Definitely, Mr. Rohan Pathak. It will not trip if the circuit breaker will be of a higher capacity. If it is of lower capacity, then it will trip down. And if the cable sizing is of lower capacity, then it will melt. So that is the basically the short circuiting will be there. Okay, there is one query from Mr. Sari is that 20 HP VRF audio, it is of 16 kilowatt. How the transformer can be selected for such system? So transformer selection, it will be based upon this is your HVAC load. Okay, so this is your HVAC load. Then we will be having another load of firefighting. Then for the plumbing also, and then for the other electrical load, we will add all these loads, and accordingly the selection of the transformer will be done. So what we will do, I will just write here HVAC load will be there, then plumbing load, plumbing and firefighting load, plumbing and firefighting load will be there, then all electrical equipments, electrical loads, and in last we have other miscellaneous load, other miscellaneous load. So transformer will be selected according to, once we will do the summation of all these, once we will do the summation of all these, accordingly the transformer selection will be done. Transformer selection will be done. Even the DG sizing is also DG sizing. It will be like that. Okay, what equipments that will be using under the DG set. So accordingly, the transformer selection or DG selection will be done. Diesel generator it will be done. Okay. What about supporting equipments like VFD for this? Definitely, if we have VFD option, then the total power it will be according to the VFD. So we would be designing it for the peak condition, and that is for the full load. There is one query that is starting current it will be high. So definitely we will see as per this column. We will insert one more column here. Right, you are right. So here what we will do, before that we will just insert one more column, and this is one of the important thing, just note it down. See here what we will do, we will write starting current also. Sometimes due to the different starters are used, that is soft starter, star delta. So starting current will always be on a higher side. Okay, so we will check whether this starting current it is greater than the factor of safety, whether this starting current it is greater than the factor of safety, this and this value. If starting current is greater than factor of safety, then we will select the MCB as per the starting current. Okay, we will not select the MCB as per the corrected current. So starting current we will also check. We will also check that whether this value it is on higher side or not. Generally it is around 1.2 to 1.5 times of this. Mr. JY law, we have to consider the starting current also. What is the power factor? In power, if there is no role of power factor in the single phase, will be just power equal to VI. So that is one value one we will be considering. Is it the same process for the HVAC? Yeah, right. In the HVAC panel, we are talking. In the panel itself, we have the outcomers and we have the incomers also. So incomers, we are taking it from the transformer, and outcomers, we are supplying it to the equipments. So that is what it is. Okay. Starting current details, it will be provided by the manufacturer. Starting current and running current. There are two types of current is there. One is the starting current and one is the running current. Running current, it is the average current, and starting current, it is the that is the maximum interest current that is required. So all these values, it is being provided by the manufacturer. There is one query that what is the MCA, that is minimum circuit ampacity, and where does it required. So this is what we are going in detail for the basics. So all these things we will be discussing in the upcoming webinar that we have for basics of electrical, that is required for any HVAC engineer. So there we will be discussing about MCA, that is your minimum capacity ampacity, minimum circuit ampacity, and where we can use that. So that is what we'll be discussing in that particular webinar. The queries that you are asking, that is in the detail of that is the difference between star and delta connection. So these are the types of starter that we use, Mr. Mithles. So that we will discuss in the basics of electrical webinar. Okay.